In this part 22 of Matrix and Determinants English series, we will solve one question concerning determinant of matrix and properties of determinant. Given that matrix A equal to this 3 by 3 matrix, what is determinant of A transpose times adjoint of A? First, let's simplify this expression. From the properties of determinant, we know that determinant of A transpose times adjoint of A equal to determinant of A transpose times determinant of adjoint of A. We can draw relationships between both determinant of A transpose and determinant of adjoint of A with determinant of A. Determinant of A transpose means simply determinant of A. Determinant of adjoint of A equal to determinant of A the power of n minus 1, where n is the order of the given matrix, which is 3. So determinant of A transpose times determinant of adjoint of A can be expressed as determinant of A transpose can be replaced by determinant of A times determinant of adjoint of A can be substituted by determinant of A the power of 3 minus 1, which is equal to determinant of A times determinant of A the power of 3 minus 1 is 2, which is again equal to determinant of A times determinant of A squared is determinant of A cube. Hence, what's expected from us is to find the determinant of matrix A and then cube it. To find the determinant of a 3 by 3 matrix, we have to express the matrix as the sum of 3 2 by 2 matrices by taking one row or column of the matrix as the coefficient of the 2 by 2 matrices. In doing so, what's recommended is to take a row or column containing more zero as a coefficient, but we don't have any zero in the given matrix. So whichever the row or column we choose, the steps we are going through is the same. For this particular case, let's choose row 1 elements as a coefficient and assign the sign of the coefficients as positive, negative, and positive. The sign is positive only when the sum of the row and column of a given element is even. In this particular case, this one is in row 1, column 1. 1 plus 1 is 2, which is even, so the sign is positive. If the sum of the row and column of a given element is odd, the sign of that coefficient is negative. This 3 is in row 1, column 2. 1 plus 2 gives us 3, which is odd. Thus the sign of 3 is negative. Next, let's form the summation. The sign of 1 is positive. So 1 times the determinant of the first 2 by 2 matrix. We will find the matrix elements later. For the time being, let's simply form the skeleton. The sign of 3 is negative, thus minus 3 times the determinant of the second 2 by 2 matrix. The sign of this third one is positive, hence plus 1 times the determinant of the third 2 by 2 matrix. To find the elements of the 2 by 2 matrices, we have to cross out the row and column where the coefficient belongs. 1 is in row 1, column 1. Removing them left us with these 4 elements. 3 is in row 1, column 2. Crossing them out gives us 2, negative 3 in the first row of the 2 by 2 matrix and negative 1, negative 3 in the second row of the matrix. This one is in row 1, column 3. Eliminating row 1 and column 3 gives us these 4 elements. To determine the determinant of the 2 by 2 matrix, we have to multiply the main diagonal elements, and from that product, we have to subtract the product of the remaining 2 elements. 1 times the determinant is the determinant itself. Thus, 1 times negative 3 minus negative 2 times negative 3 minus 3 times 2 times negative 3 minus negative 1 times negative 3 plus 2 times negative 2 minus negative 1 times 1, which is equal to 1 times negative 3 is negative 3 minus negative 2 times negative 3 is 6 minus 3 times 2 times negative 3 is negative 6 minus negative 1 times negative 3 is positive 3 plus 2 times negative 2 is negative 4 Negative 1 times 1 is negative 1. Minus negative 1 means plus 1, which is equal to negative 3 minus 6 gives us negative 9. Negative 6 minus 3 gives us negative 9. Negative 3 times negative 9 gives us positive 27. Minus 4 plus 1 gives us negative 3. Negative 9 plus 27 minus 3 gives us 15. Therefore, the determinant of matrix A is 15. To find the determinant of A transpose times adjoint of A, we have to cube the determinant of matrix A. The determinant of matrix A is 15. 15 cube gives us 3375. This concludes part 22. Take care.